Okay, good evening, everybody. Thanks for tuning in. I'm back with a rare software demo video. I tried to give a live demo for a presentation at work today and failed because I couldn't join the meeting. So that's just life in IT sometimes. Either how, here is the demo from my personal machine, and I'll try to very briefly cover the stuff that would support it from the presentation. So this little mock-up I have here is nobody's first choice of AI solution in 2025, but is a great learning tool which I came up with basically just two ChatGPT prompts. So it's a web interface to SBERT, and SBERT would be sentence BERT. It's a sentence transformer that emphasizes getting a single good embedding for a whole chunk of text. So what we have here is a bunch of input text. This would be your chunk documents or whatever piece of a document there. And if you wanted to say like add a new document, I would just hit a plus sign here, and let me try to think of one like birds of paradise often build beautiful nests. I don't know. And now let's submit that. So when we take these chunks of text and give them to the transformer, we'll get back an embedding. And these embeddings are size 384, just for the sentence transformer I've picked. But embeddings could be any dimension from a couple hundred to several thousands. So next, what I want to hit is choose one of these to be like a search query into your database. So let's pick this one about elephants. How much does an elephant weigh? And when I hit similarity there, it's going to score every single embedding against this embedding. How close are they? And of course, it's scored itself against itself and got a similarity of 1.0 for the query because it's exactly the same text, right? So of course it's similar. But we can see here we got a score of 0.89 for the similarity on the text elephants weigh a ton. So that came out as number 1. And number 2, you can see it's a much more distant 0.26. So for a retrieval system, you probably have a cutoff. It might be 0.5 or maybe even 0.7. Or you have to tune that value based on your own documents. If they're all kind of about the same thing, then you may have an issue where your embedding model gives a lot of similar vectors to everything you put into it, so you may want a higher threshold to get stuff that's really, really closely aligned with your query. But if we pick a different query, like let's pick this one about do all birds lay eggs? Of course, the word eggs appears in this one about chickens, so that's going to get a high score. But you can see if you had like a threshold of 0.5, that still would have got this one here. So I think we got the other word birds, but in this case, like birds and chickens are probably associated, which brought those two vectors very close together. So we got a 0.84. Meanwhile, this one, which references birds but not eggs, came up as 2. And then, of course, the value drops off quickly from there. So this is just my quick little embedding demo to hopefully illustrate those concepts a little bit. You don't need to see these numbers to know that it's really long, but these numbers represent that text. All right, next one. I wanted to demo my buddy Aaron's demonstrator. So this is a system built on top of a couple of different parts. It's called Hybrid LLM. The first part is the query screen where you can punch in a question to a large language model. The other parts here is being able to upload documents, and also upload documents not for vector embedding, but for an ontology, which extracts the entities and lists their connections based on the chunks they appear in, and basically makes a map of these things being connected just on the unstructured text that they appear in. So this is pretty similar in concept to GraphRAG, but it's just a little more primitive. It's the sort of thing you could build in a weekend as a minimum viable product if you want to learn how to get this up and running. And I think I actually shut down the server, so let me double check that service before I try to demo it. Okay, fired up that service. So let's take a look here. Wait, no, I didn't. Did totally the wrong parts. Okay, so with this thing up and running, let's just double check that that's going to load. Okay, so the first thing we want to do is probably get some documents and convert them to vectors. So I have this folder of Wikipedia articles, and I'm going to pick just one sort of at random. Well, not that random. I'm looking for one. Let me pick fused filament fabrication. This is a Wikipedia page about 3D printing. That's going to get split into chunks by a sentence transformer, and every chunk is going to sentence transformer. Did I say that right? No, we're going to use sentence transformer to get embeddings. We're going to use spacey, some natural language technique to get chunks out of it. So chunk, embed, and vector. Once the vectors are all stored in FAISS or FACE, then now we can do a query. Let me say something kind of obvious like, what is 3D printing? And if I hit submit query, it's going to run all of these different services. It's going to pull results out of that database. So all we did was upload a document, and we get these chunks of text. Of course, the first one in the results there is basically defining it. Seems like the header from that wiki page, and a bunch of other stuff seems to have come along. But if you remember from that embedding tool demo, the cosine similarity can drop off pretty easily. I did tweak this up to 12, which is probably too many results, but I was messing with it myself. Finally, we take all of these results and give them to a large language model and ask the model to respond specifically, like with a prompt that says something to the effect of, "Your retrieval system, read the documents and convey what they mean for the query. Don't make things up. Don't rely on your own knowledge," is a sort of thing you can ask it. So it looks like it did lean very heavily on the result here. Yeah, and there we have that. So let me put that same document into the ontology. So if I hit build ontology, this is now going to run the entity extraction and pull out all of the named entities in that document. And I do have the console for Neo4j up here. And let me just run this query again, and let's have a look at some of the entities and relationships it made. So I do see some, what do you want to call it, noise or like low quality entity tags that got pulled out. But one of the things that it did pull out of that text is FFF is related to FDM. That's fused filament fabrication, is related to fused deposition modeling. So it did get that right. Some of these things are from a prior document I had uploaded. So the more you build out an ontology, the more things that are related to it, like the wider the relations you can find for your existing entities. So that's sort of an early system there. I don't think we're getting any ontology results back. But the reason I'm interested in stuff like that is because we really want to rely on first order logic, or otherwise try to trace what the AI system is purporting to be, its logical reasoning behind its decisions, not just let it generate random text, confabulate, and basically make crap up. We don't like that. So what I'll do next is I'll find wherever my terminal went to. I want to review some of the results from doing GraphRAG. So something I did mention in my presentation is that I wasn't able to get GraphRAG to run locally with my locally running large language model. I was having issues with the embedding stage, and I think what I'm going to have to do is basically write something that emulates the API of TickToken and present my own API endpoints to get embeddings from a custom library that takes the place of TickToken in GraphRAG's code. Maybe I'm just not finding the right docs to configure it for a custom embedding model, but that's what I'm currently working on. But I did spend a couple of nickels. I think I'm up to 44 cents with queries after messing around and got GraphRAG to run. So here's what the GraphRAG init process looks like. It does take quite a while. I really think this thing makes dozens and dozens, if not hundreds of LLM calls just to, like in this case, make a graph of 50 Wikipedia articles. And that's that folder of 3D printing documents that I was working with. And after it did all of those, I can put in a query and just say something like, do a global query. What's the major techniques used in 3D printing? It's going to give a little bit of output saying like, hey, we called the model. I'm a cheapskate. I picked GPT-4o mini. And what does it come up with? This, like, not stingy at all, like a rather, I think, interesting generation of stuff sourced directly from the documents there. Another query I ran there was a drift query, and drift is probably the most interesting technique, which GraphRAG uses to switch between the individual entities, their communities, and the summaries that it wrote on the knowledge graph that it produced. And this takes a really long time. It made a lot of API calls. I think this individual query alone cost me a nickel in GPT-4o mini tokens. But I gave it a pretty hard question, which is, what are some considerations for 3D printing nylon and producing strong parts? And what did it come back with? Discussing the polymers. I know all three of those nylon polymers are pages that it pulled into the data set. I didn't hand pick my articles. I ran a different script to take some keywords and blow that up to search results and snag the full wiki text and targeted 50 page count to have some data to work with. And it's suggesting pretty decent starting point for nozzle temperature, bed temperature, and I wouldn't call this like the most brilliant creative thinking of you need to watch your layer height, but yeah, you're right. Hygroscopic. We know nylon is hygroscopic, so it's definitely pulling accurate info out of those documents that I plugged in there. I made a typo with some command there, and I did a local search or a local query, and what did it come up with for a local query with the same question? A lot faster, a lot cheaper. I can see that it pulled some of the same like general facts, like let's see, hygroscopic, bed temperature 50 to 100, nylon temperature 220 to 260. It also recommended annealing. So in this case, I would say that the local search was pretty comparable, if not just as good as the drift search for this topic. But then again, there was just a couple of documents and they were all about nylon. So it could be that this search, despite seeming like a quote unquote hard question to me, was not really that difficult for RAG to pull results directly. Drift search might be better suited for things that actually require a bit more synthesis, that you want to see a community summary as one of the inputs and a different community summary as another critical part of the input. So I know that's not super involved, but I'm going to call it there. Just wanted to put my code and examples in front of people. And if you have any questions, you know where to find me. Have a great evening.